Zener Diode characteristics and Zener as voltage regulator. Aim to plot volt ampere characteristics of Zener diode. To find Zener breakdown voltage in reverse biased condition. To calculate static and dynamic resistance of Zener diode in both forward and reverse biased condition before and after breakdown voltages. Components: Zener diode AP4735 of 1 number, resistor 1 kilo ohm, 1 number. Equipments required: breadboard of quantity 1, regulated power supply of 0 to 30 volts DC 1 number, digital ammeter of 0 to 200 milliamperes, digital voltmeter of 0 to 30 volts DC of 1 number, connecting wires. Coming to the equipments of Zener diode, one is dual RPS. RPS means regulated power supply. Now here voltage course means if you increase the voltage, the value of change voltage is very high, 1.4, 1.2.3 like that. If you increase if you using voltage fine, a small change will be occur, like 3.0 to 3.1. Here voltage variation is fine and voltage will be variation course. Okay. With this RPS we can apply voltage up to 0 to 30 volts. Here we are having two channels. We are using only one channel for the Zener diode. Now if you place in channel 2, we need to increase the channel 2 voltage. Now here we are applying for using a channel 1 only. Here is a ammeter is used to measure current. Now if this ammeter read is in milliamperes, you have to place this knob in milliampere side. Multimeter is used to measure voltages. DC voltage, it is 600 DC voltage, 200 DC voltage, 20 volts DC voltage and 2 volts of DC voltage, and this is 200 millivolts, and it measures the resistance 2 mega ohms, 200 kilo ohm, 20 kilo ohm, 2 kilo ohm and 200 ohms. Here our resistance is 1 kilo ohm. Here we are placing into the 20 kilo ohm range or in 2 kilo ohms range. The resistance of this resistor can be measured with the help of this multimeter. If you observe this, the value of resistance is 982 ohms, which is nearer to 1 kilo ohm. The resistance can be measured in two ways. One is by using multimeter, another one is by using color codes. The color coding is given by BB Roy and GBVGW. One more diode is the first terminal, which is on the left side, is called anode, and the black one is called cathode. Anode is, this is a Zener diode, this is anode, this one is cathode. Specifications of Zener diode: breakdown voltage equals to 5.1 volts, power dissipation is 0.75 watts, and maximum forward current is 1 ampere. Circuit diagram: forward bias characteristics. Circuit diagram: reverse bias characteristics. An ideal PN junction diode does not conduct in reverse bias condition. A Zener diode conducts extensively even in reverse bias condition. These diodes operate at a precious value of voltage called breakdown voltage. A Zener diode, when forward biased, behaves like an ordinary p-n junction diode. A Zener diode, when reverse biased, can either undergo avalanche breakdown or Zener breakdown. Avalanche breakdown: if both the p side and n side of a diode are lightly doped, the depletion region at a junction is widens. Application of a very large electric field at the junction may rupture the covalent bonding between electrons. Such a rupture leads to the generation of large number of charge carriers, resulting in avalanche multiplication. Zener breakdown: if both p side and n side of the diodes are heavily doped, the depletion region at the junction reduces. It occurs at a much lower voltage. This temporary breakdown occurs due to the high electric field, as it does not contribute to a chain reaction. The effect of the Zener diode is temporary. Procedure: forward bias condition. Connect the circuit as shown in the figure. Vary VZF gradually in steps of 0.1 volt up to 5 volts and note down the corresponding readings of IZF. Tabulate the different forward currents obtained from different forward voltages. Table: serial number, RPS voltage, forward voltage across the diode VZF, forward current through the diode IZF. Reverse biased condition. Procedure: connect the circuit as shown in the figure. Vary VZR gradually in steps of 0.5 volts up to 8 volts and note down the corresponding readings of IZR. Tabulate different reverse currents obtained for different reverse voltages. Serial number, RPS voltage, reverse voltage across the diode VZR in volts, and reverse current through the diode IZR is in milliamperes. RPS voltage positive is connected to breadboard, which is connected to resistor 1 kilo resistance. From supply positive to breadboard, positive is connected to 1 kilo ohm resistance. Resistance second terminal is connected to breadboard, which is from the breadboard. Again, it is connected to ammeter positive 0 to 200 amperes ammeter positive. 1 kilo ohm other end is connected to ammeter positive. Ammeter negative is connected to breadboard. From the breadboard, we connect a one wire is to Zener diode anode, and one more wire is to voltmeter positive. Ammeter negative is connected to Zener diode anode. Zener diode other terminal is connected to voltmeter positive, also connected to Zener diode anode. RPS negative is connected to breadboard ground. We will connect two more wires. One is Zener diode cathode and voltmeter negative is also connected to breadboard ground. Supply negative terminal is connected to ground Zener diode cathode terminal is connected to ground. Voltmeter negative terminal is connected to ground. Now switch on the power supply. Switch on the power supply. Now here the current must be in milliamperes. Make sure that the current limit must be in maximum position and it must be in channel 1. Now increase the voltage. Place the RPS voltage 0.1 and note down the reading of voltmeter reading, which is 0.2 and current is 0. Now again increase the voltage to 0.2, RPS voltage to 0.2 and note down the Zener voltage across the Zener diode is 0.5 and current is 0. Place the RPS voltage to 0.3 and the voltage across the Zener diode is 0.6 and the value of current is 0. Now the RPS voltage is 0.4, voltage across the Zener diode is 0.6 and current is 0.1. Again increase the voltage to 0.5. The value of voltage across the Zener diode is 0.6, sometimes 0.7. The current is 0.2. Now like that you have to step by step you need to increase. Now if you observe the voltage across the Zener diode, which is 0.7 for a RPS voltage of 0.6. Again you need to increase the voltage of RPS voltage 0.7 and the voltage across the Zener diode is 0.7 and current is 0.3. For 0.8 the value of our voltage across the Zener diode is 0.7. For the value of 0.9 RPS voltage across the Zener diode is 0.7 and current is 0.6. For a 1.0 of RPS voltage, the voltage across the Zener diode is 0.7, current is also 0.7 milliamperes. See, voltage is in volts, the current is in milliamperes, 0.7 milliamperes. Now if you further increase the RPS voltage 1.1, the value of current is 0.8 milliampere and the voltage is 0.7 volts. Now if you further increase the RPS voltage like 0.1, the value of current flowing through the Zener diode is increases, but the value of voltage across the diode is which is 0.7, which is fixed, which is called cut-in voltage of Zener diode. This is called cut-in voltage of Zener diode. Now coming to the reverse bias. For reverse bias, we just remove the supply positive and supply negative and we will interchange these two terminals. For reverse bias characteristics, you can observe the circuit diagram. Resistance is only 1 kilo resistance. There is no change in the resistance from forward bias to reverse bias, and ammeter rating is also same, which is 0 to 200 milliamperes. Voltmeter rating is also same, but there is only change is the terminals of RPS negative and positive. For reverse bias, we just switch off the power supply and reverse the positive supply positive terminal and supply negative terminal. Here is the supply positive terminal. The positive terminal is to be grounded and the supply negative terminal is connected to the resistor. Supply negative terminal is connected to the resistor first terminal. Now again you need to switch on the power supply. Now again apply the voltage. Now for reverse bias you need to apply a voltage of 1 volt. Now we are applying a 1 volt 1.0. The value of voltage across the Zener diode is which is 1.2 and the value of current is 0 milliamperes. Now if you apply a 2 volts, the value of voltage across the Zener diode is 2.4 and the value of current is 0 milliamperes. If you apply a 3 volts, the voltage across the Zener diode is 3.2 and the value of current is 0 milliamperes. Now if I apply 4 volts, the voltage appear across the diode is 3.9 volts and the current is 0.4. It is in reverse bias, that's why you are getting negative values, minus 3.9 and minus 0.4. Now apply 5 volts, the value of voltage across the Zener diode is which is 4.3 and the value of current is minus 1.2 amperes. If you apply a 6 volts, the value of voltage across the diode is 4.4 and the value of current is minus 2.2. If you observe carefully, from 5 volts to 6 volts, the value of voltage increase is only 0.41 from 4.3 to 4.4, but where the value of current is increases drastically. Now if you are placing to 7 volts, the value of voltage is 4.4, sometimes it may be 4.5, but the value of current is 3.2 amperes. Now if you place to 8 volts of RPS voltage, the value of current is minus 4.2 milliamperes and the value of voltage is 4.5 volts, which is almost fixed value. Almost as we are increasing the RPS voltage, the value of voltage across the diode which is 4.5, 4.4, 4.6, which is a Zener breakdown voltage, or further this Zener diode can be used as a voltage regulator. Now even if we are increasing the RPS voltage to 9 volts, the voltage will not increases more than the 4.5 volts or 4.6 volts. Now again you need to reduce the voltage to 0, you need to switch off the power supply. Mole graph. Plot the graph between VZF voltage which is an x-axis and IZF in milliamperes which is an y-axis, and voltage VZR in volts which is in negative y-axis, and IZR in milliamperes which are in negative I-axis or negative y-axis. Calculations from graph. Static resistance RDC equals to VZF by IZF. From the forward bias characteristics tabular column, VZF, here considering a point from the graph or from the table, 0.7 is the voltage and corresponding current is 0.5 milliamperes. 0.7 by 0.5 into 10 power minus 3, which will use 1.4 kilo ohms. Dynamic forward resistance RAC is change in VZF by change in IZF. 0.7 minus 0.6 is the voltage change and corresponding current change is 1.7 milliamperes and 0.1 milliamperes, which will give us 62.5 ohms. From reverse bias characteristics, we can find out static reverse resistance RDC equals to VZR by IZR, which is equals to 4.5 volts by 4.2 into 10 power minus 3, which will give us 1.07 kilo ohms. Dynamic reverse resistance RAC equals to change in VZR by change in IZR. 4.5 minus 4.4 by 5.4 minus 2.2 into 10 power minus 3, which will give us 31.25 ohms. Precautions. While experimenting, do not exceed the ratings of the diode. This may lead to damage the diode. Connect the voltmeter and ammeter in the correct polarities as shown in the circuit diagram. Do not switch on the power supply unless you have checked the circuit connections as per the circuit diagram. Result. From the forward bias characteristics, cut-in voltage is equals to 0.6 volts. Reverse breakdown voltage is minus 4.5 volts. Static forward resistance is RDC is 1.4 kilo ohm. Dynamic forward resistance RAC is 62.5 ohms. Static reverse resistance is 1.07 kilo ohms. Dynamic reverse resistance is 31.25 ohms. Conclusion. From the VA characteristics of the Zener diode, cut-in voltage, breakdown voltage, static resistance, and dynamic resistance are calculated. Thank you for watching. Please like, share, and subscribe if you like.